Okay, so I'm going to go ahead and get started in 3.6. 3.6 is actually a two-part. So this video is going to contain 3.6a and 3.6b. So now we're talking about the transformations of those sinusoidal functions. You have your standard equation. So this is what it looks like with its transformations happening. And now I'm reusing the same vocabulary that we just had, only now it's a little bit different because we're talking about uh the sinusoidal functions that have transformations, right? It's not like the parent functions before. So the amplitude though is still the absolute value of a, but now in this case my midline is going to occur at D. So this vertical shift up or down is where my midline is now going to occur. Okay, now my period is going to be 2 pi divided by b. So whatever, remember that b represents a horizontal stretch or shrink, right? A represents a vertical, but the A represents the horizontal, meaning how smushed or spaced out my graph is going to look. And I will show you examples of what that looks like. So if you had a function that had a horizontal stretch or shrink, you may have one that looks like this, like really, really tight, or you can have some that are like really long, like that. So that's what happens when you have a horizontal stretch or shrink in this case, which is why you have to divide by b for the period, and why in the frequency it's the reciprocal. So it's 2 pi over b. Okay, so now here you have some examples that you are going to have to work out, right? Um, but I'll do the first one. I won't do the graph, but we'll do the first one. So the amplitude is going to be the absolute value of A, which in this case is 3. So it's just 3. My period is going to be 2 pi over 2, which cancels out, leaving my period as just pi. My frequency is going to be the opposite. So the nice thing with the frequency is that since I know what the period is, I just have to do the reciprocal, right? So it's 1 over pi. And just in case you don't believe me, my frequency, I'll calculate down here, would be 2 over 2 pi, which again would just cancel out, and I would have 1 over pi. And then my midline is going to occur at y equals 0. There's no plus d. So meaning it's not moved up or down, so that's going to stay the same. And then my maximum value is going to be 3, while my minimum is -3. That's what the amplitude tells me. The amplitude is what's going to determine your maximum and your minimum points. Okay, and then you would graph it. So you would have to do number 2 on your own, but at least you know what to do with that first one. And that's actually the end of 3.6a. So now we're just going to move straight on to 3.6b. So in 3.6b, it's a continuation, but now we're going to include, so because the focus of this lesson is to learn about the phase shift of a periodic function. So essentially it means a horizontal translation. And my screen stopped sharing. So let me see about fixing that. That should be better now. There we go. So I don't know where it got cut off. This was the answer for number 1. And that's the end of 3.6a. So now 3.6b is now with the introduction of the shift left to right, which I'm going to write in as a plus c. Okay, and then remember that these are always going to be their opposites, right? So in this example, I have the 3 cosine of x plus pi over 4. plus 2. So my amplitude, once again, is just the absolute value of 3, which is just 3. My period is going to be 2 pi over b. But now there's no b here, it's just 1. So it's just going to be over 1, or just 2 pi, meaning that my frequency is 1 over 2 pi. My midline, well, now I have a plus 2, so it is going to be at y equals 2. Now my maximum and minimum are going to change. So in clarification with the previous example, I did not have a shift up or down. So my midline remained at that at y equals 0, right? Which was easy for the amplitude. Now for my maximum and minimum, I'm going to have to combine my values of amplitude and the midline, right? So a maximum would be 3 plus 2, which would give me a 5, while the minimum would have to be a negative 3 plus 2, which would equal negative 1. So remember that the amplitude is going to be positive for maximum, and your minimum is going to dip under. So it's going to be at negative 3. But since I have that midline of a plus 2, I need to move my graph up 2 units. Now the phase shift. So remember that if it's a plus, it's really to the left, and it's to the left by pi over 4, not 2. Pi over 4. Okay, so that's the example that I did with you all. So you will have to do the rest on your own. And that's actually the end of 3.6.